So in this video, we're going to find the equation of the tangent line to a given curve by using the limit definition. So we know that by limit definition, f prime at point A is going to be the limit as h approaches 0 of f of a plus h minus f of a all over h. So that's the limit definition to find f prime at a, the derivative at a. And that is going to be the slope of this tangent line. Now, what is our a value? Well, this is our a. So our derivative at 4 is going to be the limit as h approaches 0 of f of 4 plus h minus f of 4 all over h. So I'm going to simply evaluate f of 4 plus h using this function. So we're using y equals square root of x. So let's go ahead and do that. We have the limit as h approaches 0 of, so plug in 4 plus h into your function, placing x, that'll be square root of 4 plus h minus f of 4, so evaluating the function of 4 all over h. And then just simplify this algebraically. We have the limit as h approaches 0, a square root of 4 plus h minus, well, we know square root of 4 is as 2 divided by h. Now here we might have to use some algebraic technique to simplify this limit. So recall that if you have a minus b and you multiply it by a plus b, you get a squared minus b squared. So this is what we know as the conjugate of an expression. When you multiply them, you get the difference of two perfect square. So in this case, I have this form. So the conjugate will be a square root of 4 plus h plus 2. So that when I multiply it top and bottom of this limit, I get a square root of 4 plus h squared minus 2 squared. So multiply top and bottom by the conjugate. So you'll have the square root of 4 plus h plus 2 and square root of 4 plus h plus 2. So I'm going to do that, put parentheses around, and this will give us the following now. We have the limit as h approaches 0. So on top, when you expand, you get the difference of two perfect squares. So that would be 4 plus h. And so when I distribute this, the square root cancels out. And then the middle term cancels out, and you're left with minus 2 squared, which is 4, all over square root of 4 plus h plus 2 times h. So that doesn't cancel or anything yet. And then on top, we see that the 4 and negative 4 cancels out. And this leaves us with the limit as h approaches 0 of h over h times the square root of 4 plus h plus 2. And now here, I realize that I can cancel the h's from top and bottom. And that leaves me with the limit as h approaches 0 of 1 over the square root of 4 plus h plus 2. And now we're ready to take the limit. So plug in h equals 0. You have 1 over a square root of 4 plus 0 plus 2, which is simply 1 over square root of 4 is 2, that's 2. So that's going to be 2 plus 2, 4. So that is the slope of the tangent line. So this is our slope of the tangent line. So now that we have the slope, we want to write the equation of the tangent line at x equals 4. Well, we need to find the y coordinate of that point. So simply plug it into the function. So we know the slope. Now the point we're going to be using is x equals 4. And y value is determined by simply plugging 4 into this equation. That gives you square root of 4. That would be 2. So we know the point, we know the slope. Let's write out the equation. So the equation of the tangent line is going to be I'll write using the point slope form. So you have y minus y1 equals m times x minus x1. And we plug in our points. So this is y minus y1. That would be 2. M is the slope. That's 1/4. And then x minus 4. And then if you want to write this in point slope form, you can also do the slope intercept form by simply solving for y. So you have y minus 2 is equal to, distribute the 1/4. So that's 1/4 x minus 1. And add 2 to both sides. You will have y is equal to 1/4 x plus 1. So that's the equation of the tangent line in slope intercept form. Now let's picture this. What's really that we obtain right now? Well, we have this graph of y equals square root of x, and we all know that square root of x looks something like this. We know that by now. So this is y equals square root of x. We're looking at x equals 4. So let's suppose 4 is right here. So x equals 4 is this point, and we know y value is 2. So the line we just computed is the tangent line. So that will be the line that passes through the point 4, 2. So, and it touches the curve only at a single point. So that's the tangent line we just computed. That's right here. So that's the graphical illustration of what we just computed. Okay, let's go ahead and do another example. So here we also want to find the equation of the tangent line. So to find the equation of the tangent line, we need the slope, which will be our derivative at that point, that is 2 in this case. And we also need the point itself. So we know the x-coordinate is given, that's 2. And how do we find the y-coordinate? Well, we simply plug this in here. So that will be k evaluated at 2. So k of 2 is going to be 1 over 2 plus 2. It's 1/4. So we know the point the tangent line is going to pass through is 1/4. So now the only thing remain to find is the slope. So let's go ahead and do that. We're going to be using the limit definition one more time. So the derivative at 2 is going to be the limit as h approaches 0 of f of, well, in this case we're using k, so I'm just going to switch the notation to k prime. So it'll be k of 2 plus h minus k of 2 divided by h. So for k of 2 plus h, we're going to plug in 2 plus h into the function and replace it where x is. So we have the limit as h approaches 0. K of 2 plus h is simply 1 over 2 plus h minus k of 2. That's going to be 1 over 2 plus 2. So I simply replace it right here where the x is in the function. And we're dividing all of this by h. So carrying out the algebra, we have the limit as h approaches 0 of 1 over. Now here I can drop these parentheses and I can add 2 and 2. That gives me 4 plus h minus 1 over 4 all over h. Now I cannot take the limit until I simplify this. So I'm going to go ahead and combine the top into a single fraction by simply multiplying by the LCD. So I multiplied this with 4 plus h over 4 plus h, and this with 4 over 4. And then we are able to combine the top into a single fraction. So this gives us the limit as h approaches 0 of 4 minus 4 plus h. So be careful with the negative. And on the bottom we have the common denominator, 4 times 4 plus h all over h. And here I'll distribute the negative out. So we have the limit as h approaches 0. 4 minus 4 minus h all over 4 times 4 plus h. Now instead of writing over h, I can reciprocate that and write times 1 over h. So I just reciprocated the bottom fraction. And now here we realize that the 4 and -4 cancels out. So this leaves us with the limit as h approaches 0, negative h over 4 times 4 plus h times 1 over h, which I reciprocated earlier. And now I see that the h's can cancel out. That leaves me with the -1 on top. So we have the limit as h approaches 0 of -1 over 4 times 4 plus h. Now I can plug in h equals 0. So I have -1 over 4 times 4 plus 0. That would be 4 times 4 on the bottom, -1 over 16. So that's the slope at x equals 4. So we found the slope. We have the point right here. Now let's go ahead and write out the equation of the tangent line. So our tangent line, the equation of it, it's going to be y minus y1. Well, that's the y coordinate, that's 1/4, equals m, that's -1 over 16, x minus x1, that'll be the x coordinate of the point, as 2. So there you have the equation of the tangent line to a different curve at a different point.